Hi, everyone. We're looking at the next chapter of our semester review, chapter 11, which is all about area. So just to refresh our memories on some of our different formulas for a parallelogram, which includes the rectangles and squares, they all had a very similar formula, which is the base times height. So regardless if we're looking at a parallelogram or a rectangle, we're looking for the 90 degrees, and that's where we're going to find out where our base and height are, because they will always make a 90, whether it's inside the shape or outside the shape. So looking at our rectangle, it's easily side times side, and some people know it as length times width. Now, looking at the parallelogram, those slanted sides are not making 90 degrees, so you have to find that 90 first. That is where you're going to locate your base and height. So, and then with a square, again, locate a 90. And the nice thing about squares, each corner is a 90. So it doesn't matter which set of sides you use, as long as they make a 90-degree angle. And the square has a little bit different version of that. It is still base times height, but since base and height are the same side, they're all equal, we can just take the one side and square it, multiply it by itself. All right, now let's look at the triangle. Now, keep in mind with triangles and parallelograms and anything that might possibly have a slanted side, sometimes, just like this picture, the height might be outside, but it's always going to be connected to the 90 degrees, whether it's inside or outside, always connected to the 90. The base is always the side of the triangle that the 90 degrees is made from, even if it's a dashed part like it is for this obtuse triangle. But remember, the dashed pieces that are there are not part of the actual shape. They are only there to help you see that the base and height make the 90. So triangle has base times height, divide by 2. Next, we had trapezoid. Okay, trapezoid needs both of the bases. And again, the height will be a 90 degrees. Look for that. This of a trapezoid, the area formula is very similar to the median that we saw yesterday. But for trapezoid, base times base 1 plus base 2, then times the height over 2. And if you notice, that is similar to the mid-segment one. So I know we looked at mid-segment yesterday, but there it is again for reference. And again, mid-segment connects the midpoints of the legs. All right, our next two figures that we're going to look at have the same kind of formula. They did not have bases and heights because, again, it's all about where is the 90. And in a kite and trapezoid, those 90s are inside the shape. Same thing for the kite. The 90s are inside with the diagonals. So the diagonals act like the base and height, but they use the same formulas. We need the entire diagonals. To make up our two formulas, and same for the other one. We need both diagonals because that's what makes up our area formula. Diagonal 1 times diagonal 2 will give us the whole entire area. So again, for these, the diagonals are acting like your base and height. Our next polygon that we looked at was for any regular polygon. Again, these are for the ones that have sides that are more than 4. And we have to use the apothem. So remember, we need 3 numbers. We need the A, which again stands for the apothem. So there's our A. We need a side length. And we need to know in the number of sides. Once I know all 3 of these numbers, we'll just plug it into our formula. Oops, that's supposed to be a highlighter. Apothem times side length times number of sides, and that'll give us the area of that regular polygon. All right, our next area that we looked at was for circles. This is not a polygon because it doesn't have any flat edges, but specifically what this circle needs is a radius. Radius has to go center to edge. If we have all the way across, that is the diameter. So just keep in mind the radius is going to be half of that diameter. And we have a formula, just one formula for area, pi times r squared, but we do in fact have two of them for circumference, 2 pi r or pi times the diameter. Either of those would get you the formula for circumference. So guys, I hope you enjoyed refreshing your memory about our area formulas. Please don't hesitate to reach out if you have any questions.